In this video, we're going to take a look at Unit 2, Lesson 12, which is about proofs about quadrilaterals. So first off, what we're going to do, or what we did, was take a class survey and determine which statement or statements you agree with out of these two statements. So the statements are that all rectangles are parallelograms, and then also that all parallelograms are rectangles. So decide which of those statements you agree with, and then we'll take a look. All right, so let's take a look at some of these statements in action here. So we've got this one that appears to always be, so we see that it's always a rectangle. So A, B, C, and D are always staying 90-degree angles. And it's also a parallelogram because those opposite sides are always staying parallel. So if we take a look at this next one, this one, okay, does not stay a rectangle, but it is always a parallelogram. Okay, so we've got a parallelogram. It's not always a rectangle. Okay, this one here, always staying a rectangle, and also a parallelogram. So those sides are always parallel. Those angles are always 90 degrees. And then this one, parallelogram, but not necessarily a rectangle. Okay, so the angles are not staying 90. But when the angles are 90, it appears that it does have to stay a rectangle. So what that means is that all rectangles are definitely parallelograms. So every time it had 90-degree angles, it was also a parallelogram. It also had parallel sides. However, if it's a parallelogram, meaning that the sides just have to be parallel, it does not always have to be a rectangle, okay? So this one is not necessarily true. All right, so go ahead and write this in your reference chart. So when we have a quadrilateral, if it has 4 right angles, that makes it a rectangle. So that's the definition of a rectangle. And then a rhombus is a quadrilateral that has 4 congruent sides. So make sure you get the diagrams marked up here, get the 90-degree angles written in for the rectangle, and get the sides marked congruent for the rhombus. Then we're going to start looking at some proofs today in parallelograms and proving that some things are parallel. So in order to do that, we're going to have to make sure we remember how to prove that lines themselves are actually parallel. So in this case, if we don't know that the lines are parallel yet, what we want to see is alternate interior angles congruent. If we see alternate interior angles congruent, that means these lines have to be parallel. Okay, so alternate interior angles congruent forces parallel lines is what this is saying. So the way this will show up in a parallelogram here is going to be, you're going to see kind of angles like this. So we've talked about how that creates kind of a Z. So we get this Z here with the angle and that middle line. So that's going to make these two lines parallel. Okay, so these alternate interior angles force parallel. Another way that we will prove that lines are parallel, or another way to prove it, is to see that corresponding angles are congruent. So remember, a translation will just pull a line parallel to itself. That keeps the angles congruent. So the backwards version of that, or the converse, is that if we see corresponding angles congruent, that will force lines to be parallel. So corresponding angles being equal forces parallel lines. This one doesn't show up as often in quadrilaterals, but a way that it could show up is if for some reason you happen to see something like this, and kind of these extensions of the lines, and maybe you saw then that this angle was congruent to this one. So you're going to have if you're getting corresponding angles, are kind of going to be out, one of them is going to be outside of the parallelogram, but this would force those lines to be parallel. Then another one that you are going to see today and use is that if two lines are perpendicular to the same line. Okay, so both these two kind of horizontal lines are perpendicular to this vertical line, then they're parallel to each other. Okay, so if they're perpendicular to the same line, that forces them to be parallel to each other. So this is certainly going to show up in your parallelograms, okay, if you see something like this, because then this top line and this bottom line are both perpendicular to this line. So then they're going to be parallel to each other. So what we're going to be doing is looking at a couple of statements here. And so we're going to get a statement similar to what we got with all parallelograms or rectangles. So we're going to think about the conjecture. If you're in class or with somebody, you can discuss it with a partner, get a plan together of how you're going to prove it, and then we're going to repeat this with new conjectures. So if you're in my class, you have a little foldable that you're going to be using. Otherwise, you can write this in your student workbook. So the first statement that we're going to look at is that all rectangles are parallelograms. So first, I want you to think about what is the information that we know and what are we trying to prove? So what we know is that we have a rectangle. So this is what's known. And then this is what we're trying to prove, that when it's a rectangle, it's also a parallelogram. So then we're going to kind of break down what do we know about rectangles. Okay, so rectangles, we know that the 4 angles equal 90. And then what is it that we would be needing to show for a parallelogram? So for a parallelogram, we need to show that both pairs of opposite sides are parallel. Then we would have it. So let's go ahead and look at a diagram. So part of what's going to be helpful for you is to draw a diagram. So we want to draw a diagram of a rectangle. Label the pieces. Then we talked about what we know. So we know that each of those angles are equal to 90 degrees. And then we want to show that opposite sides are parallel. So in this case, we want to show that AB is parallel to DC and that AD is parallel to BC. So this is similar to the third way we looked at to prove that lines are parallel, because we see all these 90-degree angles. So we know that different sides here are perpendicular to the same line, and that's going to force them to be parallel. So when we go ahead and write our proof, we're going to say that. Okay, so in this first part, I say AB. So let me get a segment here. So I say that AB, whoops. So AB and DC are both perpendicular to AD, therefore they have to be parallel. Okay, and then we do a similar thing. So then, whoops. So then that proves that those two are parallel. Then we can do a similar thing. So then we can say AD and BC are both perpendicular to DC. So then they have to be parallel. That means that I've just proven that both sets of opposite sides are parallel. Therefore, ABCD is definitely a parallelogram. All right, so we're going to look at 4 more statements. And so in this one, it says, if a parallelogram has at least one right angle, then it's a rectangle. So go ahead and draw a diagram. Okay, put in a right angle. So what do we know? So we know it's a parallelogram, so we know that the opposite sides are parallel. They also told us we have a 90-degree angle. So in order to prove that this is a rectangle, we need to show that all of the angles are 90-degree angles, not just the one. Okay, so in order to prove this, we need to show that. Well, so if we think about parallel lines, we know if two lines are parallel and one of the lines is perpendicular to a different line, then both lines are perpendicular. So that's what we're going to do here. So we know that AB is parallel to CD. Therefore, AD is perpendicular to both lines. Okay, so AD is perpendicular to AB, and then AB and CD are parallel, so got to be perpendicular to both. Okay, so then that means that we would have angle D as a right angle now. Then, since it's a parallelogram, we've already talked about that in a parallelogram, opposite angles are congruent. So now that we have these two as 90-degree angles, we also know that angles opposite them are congruent. So we know that A is equal to C, so it's a 90-degree angle. And we know that D and B are congruent, so B is a 90-degree angle. So now we've shown that all four angles are right angles. That makes ABCD a rectangle. Okay, next statement. If a quadrilateral has two pairs of opposite sides that are congruent, then it's a parallelogram. So we're going to draw a diagram with the stuff that we know. So remember, we know kind of this first part. It's a quadrilateral with two pairs of opposite sides congruent. And then we're trying to prove, okay, this part. So we're trying to prove that it's a parallelogram. So draw a diagram with two pairs of opposite sides congruent, label the letters so you can write it out in your proof. So what do we know? Okay, we know the opposite sides are congruent. What are we trying to prove? That the opposite sides are parallel. So this one, in order to get parallel lines, we need something with the angles. So in this one, we're actually going to put in an auxiliary line. Okay, so a middle line here. I'm just going to make it blue. So we're going to put in this auxiliary line to split it into two triangles. Because if we prove that these triangles are congruent, then we're going to be able to prove that the alternate interior angles are congruent, or corresponding angles are congruent for the triangles, which will get us alternate interior angles ultimately. Okay, so we're going to prove the triangles are congruent. Then we want to show that these two angles are congruent to each other and that these two angles are congruent to each other, so we can get those Z's. So we know that AB and CD are equal. We also know BC is equal to AD because it was given to us. So we've got those two sets of sides. We also know that BD is congruent to itself because of reflexive property. So now what we know about these two triangles is that they're congruent by side, side, side. Now that you've shown that the triangles are congruent, that means their corresponding parts are congruent. So all of those different angles are congruent to each other. So then we're going to talk about, so now let me get a couple different colors here. So therefore, angles CBD and ADB. So CBD is this one. ADB is this one. So now we know those two are congruent to each other. Okay. We also know that ABD, so ABD, this one, is congruent to CDB, this one. This tells us that these two lines are parallel. So from this orange angle, we get this Z. So that's going to give us AB is parallel to CD. Okay, and from these two angles, from these pink angles, we get this Z, meaning that BC and AD are parallel, okay, because the alternate interior angles are congruent. So now that you've shown that this line is parallel to this line and that this line is parallel to this line, you've shown that ABCD is in fact a parallelogram. All right, third statement, well, kind of fourth statement. If the diagonals of a quadrilateral both bisect each other, then the quadrilateral is a parallelogram. So looking at what we know, we're going to draw a picture based on that. So we're going to have the diagonals of a quadrilateral both bisecting each other. And then we're going to be trying to prove, again, that it's a parallelogram. So let's take a look at a diagram. So we're going to draw in something that looks like a parallelogram since we're trying to prove it's a parallelogram. diagonals in there. So label the intersection as E so that we'll be able to talk about it. And then bisecting, so marking up those pieces as congruent. So what do we know? AE is equal to EC, BE is equal to ED. And what are we trying to show? That those opposite sides are parallel. So this is going to be similar to the last one where we're going to need to prove some sets of triangles are congruent here. Then we'll be able to take their parts to get alternate interior angles that are congruent and prove the lines are parallel. So we know that AE and EC are equal, BE and ED are equal because it was given to us. Okay, we also know that angle AEB is congruent to CED because they're vertical angles. This helps me to prove that these two triangles are congruent, so ABE and CDE by side angle side. So we see the two sets of sides with the angle in between. Now that we know that those two triangles are congruent, okay, then we can steal some of their corresponding parts. So since they're congruent, we know that angle BAE, so this angle here, is congruent to angle DCE. And these angles being congruent are alternate interior angles for side AB and CD. So that means that AB and CD are going to be parallel since we see alternate interior angles equal. So now you would do a similar thing, okay? So I'm just going to write that. So in a similar fashion, we would be able to show that these the top and bottom triangles are congruent, right? By doing a vertical angle, okay, vertical angle. Then stealing corresponding parts. So this angle and this angle, which gives us a Z, which then would get us parallel lines. So in a very similar fashion, we would show that BEC and DEC are congruent, showing congruent alternate interior angles, which makes BC parallel to AD. So I'm just not going to write that all out. Then we've got both pairs of opposite sides are parallel. That would give us a parallelogram. All right, last one. So if the diagonals of a quadrilateral both bisect each other, okay, so the diagonals of the quadrilateral are going to bisect each other and they're going to be perpendicular, then the quadrilateral is a rhombus. So now we're trying to prove rhombus. So we're going to draw a diagram that has diagonals bisecting each other and perpendicular. So that's what we know. And then what we're trying to show is it's a rhombus. And a rhombus means that all the sides are congruent. So we need to show that all these sides are congruent. So if we look at this, okay, hopefully we see that all these triangles are actually congruent, okay, because we've got a 1 tick mark and a 2 tick mark side on all of them. And then we also have 90-degree angles everywhere, right, since these are perpendicular. So all of these are 90-degree angles. So once we prove that all those triangles are congruent, then their corresponding parts are congruent. And then that would be all the sides are congruent. So we know that AE and EC are congruent, BE and ED are congruent, and that all 4 of these angles are right angles because it was given to us. So we were told that the lines were perpendicular. That creates the 4 90-degree angles. Now we know that all of those triangles, because they all look like this, okay, they all have a 90-degree angle. This shorter side has 1 tick mark. This longer side has 2 tick marks. So all of these triangles are congruent by side angle side. Now that we know that the triangles are congruent, their corresponding parts are congruent. So this hypotenuse in all of the triangles is congruent because those are all corresponding sides. So AB, BC, CD, and AD are all congruent. Therefore, ABCD is a rhombus since we've shown why all 4 sides are congruent. All right, one more thing for your reference chart. So we proved this in one of the statements that if we've got a parallelogram and a 90-degree angle, that it has to be a rectangle. So now you wouldn't have to ever prove that again. If you see a parallelogram with one 90-degree angle, all of them are 90 degrees. And you can kind of take a look at the summary. You can box in those bullet points, read over them, because those are some important things about quadrilaterals, different types of quadrilaterals. Also, this paragraph here, knowing how to decompose quadrilaterals into triangles to use the diagonals helps us prove different things. So that's what we did, you know, in here, where we had a parallelogram and we kind of cut them. And then we had a bunch of triangles that helps us prove different things. And then you can try this cool down. If you need help, make sure that you reach out to me or to your teacher.